All right, another real-world example here at the Mindful Physicist. So, let's suppose we have this little Arctic fox. And it's frolicking in some Arctic tundra, right? And because you never know what I'm actually drawing, I will label this a fox, right? And let's suppose that this fox has a surface area of roughly 1.5 meters squared. And let's suppose that this Arctic fox has a body temperature, maintains a body temperature of about 35 degrees Celsius, but it lives in a place that has a temperature T naught of about 0 degrees Celsius. Okay, the question is, at what rate does this fox lose energy to its environment, right? This is an important question because the rate at which it's losing energy to the environment has a lot to say about how much calories this fox needs to consume in order to survive and maintain its body. Okay, so the question is, at what rate, Q, is this fox losing energy? All right, so it turns out there's something called the Fourier Heat Equation, right, that gives you the rate at which an animal is losing energy, right? And that formula is K A delta T over D. All right, what does all this mean? So first of all, K is the heat constant for fur, okay? A is the area, the surface area of this fox, and delta T is the difference in temperature between the fox's body and the environment itself, right? D, finally, lastly, is the thickness of this fox's fur, because that matters, all right? And so the thickness of this fox's fur is gonna be about 3 centimeters. Okay, so at what rate does this fox lose energy to the environment? Let's figure it out. Okay, so it turns out that the heat constant for this fox, K, is, for fur in general, is about 0.035. This obviously is different per animal, but it's 0.0335 watts per meters, right? And the surface area, we already have it, of this fox is 1.5 meters squared, right? And lastly, the temperature difference is the difference between the body of the fox and the environment. 35 minus 0 is just 35 degrees, is that temperature difference, right? And lastly, we said that the thickness of this fox's hair is about 3 centimeters, in other words, 0.03 meters. Okay, putting that all in, we get that this fox is losing energy to the environment at a rate of 61.25 watts. Okay, in other words, that means 61.25 joules every second. Now, if we want to make this valuable to us in terms of knowing what the nutrition of this fox needs to be, this is not very helpful because we don't usually think of food in terms of joules per second. We usually think of food in terms of the amount of calories we need to eat per hour or per day, okay? How do we convert this? Well, first things first, we know that in 1 food calorie, in other words, 1 kilocalorie, there is 4,186 joules, right? So if I divide this number, right, then immediately I find out that this fox is consuming losing about 0.014 calories every second. Again, not too helpful, right? Because we need to know how many calories per hour that this fox is going to want to have to eat, right? All right, well, we know that there's 3,600 seconds, 60 times 60, 60 minutes in an hour, 60 seconds in a minute. So it's times 3,600 seconds to find out how many calories this fox is consuming per hour. All right, what does that tell us? It tells us about 52.7 calories or kilocalories per hour. Right? So just by knowing this information, the thickness of the fur, what the heat constant is for the fur, what is the difference between the fox's temperature and the environment's temperature, and how thick is the fur, I can tell you just to keep this just to keep the lights on for this fox, it needs to consume 52.7 calories per hour, which is not nothing. It's got to hunt for that. We're talking, you know, a small fish every hour, at least. There's a lot of hours in a day. All right, now we have it.